Hi, I'm Alan Kummer, the Programs Manager of the Student Space Programs Lab. We're here to talk about some of the projects that we're working on, the OSIRIS CubeSat in particular, and then how it kind of ties in with the Lunar Lion. So this is looking at how the sun interacts with the Earth, particularly when there's solar flares and material is coming off the sun and into the Earth's atmosphere. So we're looking at using CubeSats, satellites that are about 10 centimeters on a side. What we're using for that is CubeSats. These are 10 centimeter cubes. We plan on flying 3 of these in formation around the Earth and look at the change between measurements from each CubeSat, so one CubeSat to the next. We call them OSIRIS Light and OSIRIS Light 2. What they are doing is, I have here one of the models of OSIRIS Light. We're building up the spacecraft bus and the electronics that will make that up, and the processes that will make up the spacecraft bus, and going to fly those on a high-altitude balloon to about 110,000 feet, or about 30 kilometers in altitude. And it'll be a day-long flight to demonstrate that we can generate our own solar power, transmit data back to the ground, operate like a satellite. First iteration we're doing is much larger than the initial CubeSat will be, and the purpose for that is to be able to develop the technologies beforehand and test them out. So we're doing this as kind of a development test setup. So one of the technologies that we're testing is our ability to generate solar power. This is a solar panel that we're developing, which is using solar cells from Boeing Spectral Labs, and coating them with a special coating to increase the return path for our science instrument. One of the things that we're testing is a radio that has been developed by a student here from his sophomore to his junior year in college. And what's interesting about that is that radios are very temperamental because they deal with radio frequencies that many consider to be a black art to work with. And to be a undergraduate student developing such a device is pretty impressive. Our student has gone through the process of looking at other what radios are out there, how they work, and then developing his own radio because those radios did not meet our needs. So what he's doing is he's developed this test board to fly on our first CubeSat, he's going to fly this on our first balloon payload, O-Light, which will fly in September, to demonstrate that he can close a link, communicate data down to a ground station, and doing this all within a circuit board and radio that was developed here at Penn State. This is unique because many students are not able to do this even within electrical engineering, and so it's just kind of impressive that a student can take this from his sophomore year and develop it in a matter of 2 years to something that will eventually be on a CubeSat. We're going to be flying both balloon payloads, O-Light and O-Light 2, in September, and this gives us a unique opportunity to work with the Lunar Lion and test out some of the technologies that they are looking at using for their flight. So one of the things that we've been looking at doing for the Lunar Lion is using commercial cell phones, camera phones, as the main cameras for the lander and for the spacecraft itself. So one of the things to advance that technology and be able to actually use cell phone cameras on this space flight, we're going to test the camera on a balloon flight first. So develop it and test it as kind of a demonstration that a cell phone can survive in a space-like environment, low atmosphere, cold temperatures, hot temperatures. Demonstrate that it can work in that environment, and then we hope to be able to apply that to further down the line, using that on the Lunar Lion itself. The benefit of having cell phones is that, or using cell phones and cell phone camera phones, is that they are relatively inexpensive compared to space-rated hardware, and this is something that has the entire system integrated within it. It can take dynamic video. One of the requirements for the Google Lunar X Prize is that you have to shoot high-resolution video. So modern cell phones like the iPhone are capable of taking 720p video and compressing it down to something that we can send down as our media broadcast. So flying on the balloon will allow us to develop what's called the technology readiness level of the cameras for spaceflight. Over the course of the summer, we're going to look at a number of different cell phones, Droids, iPhones, HTC cell phones, and look at being able to use those and interface with those actually on the space flight. So we may fly a number of cameras to demonstrate which one will actually be the best fit for our end mission requirements.